Hello, sixth graders, and welcome to 4.3. Today we'll be discussing equivalent expressions. We're going to mix in a little bit today some algebra, as you see from our lesson objective here. We're going to factor numerical and algebraic expressions. So a numerical expression is just numbers. So like down here where it's 27 plus 39, or an algebraic expression, it contains letters, right? And write equivalent numerical and algebraic expressions. So there's a little bit of vocabulary involved and a little bit of algebra involved this section. So hang tight with me. I'll do my best to explain it. It's probably going to be some of the first time you're seeing some of these things. So I don't want you to get worried about it. I don't want you to stress over it. It's the first time. It might take a little bit to understand it the first time. But again, don't be worried. I'll do my best to explain and we'll get some practice. All right, all that being said, the first vocabulary word we have is term. And the terms of an expression are the parts that are added or subtracted. For example, if I had like x plus 3 plus 2x, this expression has three terms because I'm adding three different parts. I have an x, I have a 3, I'm also adding a 2x. So this expression has three terms. The first term is x, the second term is 3, and the last term is 2x. The way you can find them again is they're being added or subtracted. So if you just split your expression at the addition sign or the subtraction sign, you can see your different parts or your different terms. The next word is coefficient, and a coefficient is a number that is multiplied by a variable in an algebraic expression. All right. I like to define it as it's the number in front of the letter. So for example, if I had 3x, my coefficient would be 3. It's the number that is multiplied by a variable. So it's saying take 3 times x, right? It's just the number in front of the variable. And lastly, equivalent expressions is when, so I'll just say equivalent expressions have the same value for all values of the variable. Okay. All right, so some new and maybe a little bit challenging vocab there, but again, we'll take it piece by piece. In the first example, get started right away, it says factor the sum of terms as a product of the GCF and a sum. Wow, that's pretty wordy. Okay, what they're saying is take this expression, 27 plus 39, and basically rewrite this expression, right? If you remember from when we did the distributive property, this is kind of like doing the opposite of the distributive property, all right? So first it wants us to definitely find the GCF. Okay, so that's from last section. The GCF, the greatest common factor of 27 and 39, well, they just go ahead and tell us it's 3. Okay, the two terms are, well, the first term is 27, and the second term is 39. All right, so now it wants us to rewrite 27 as a product, so 27 multiplied by its greatest common factor. Well, 27 written in terms of being multiplied by 3 would be 3 times 3 times 3. Because 3 times 3 times 3, well, 3 times 3 is 9. 9 times 3, 27. Plus, we have to add to that. That's why you see the addition sign here. We also have to write 39 as a product of its greatest common factor. So we'll instantly put down 3 because that's the greatest common factor that we took out. And 3 times what number will give you 39? Well, that would be 13. Okay. So if I were to rewrite each term as a product with the greatest common factor, okay, well, the greatest common factor we determined is 3. And 3 times what number is 27? That would be 9. Plus 3 times what number is 39? Well, 13. Okay. And lastly, it wants us to apply the distributive property. So that's when, remember, we have our parentheses, and we're adding a couple things, and then whatever's on the outside, we're multiplying the entire thing by. Well, okay, I'll just tell you now, you put your greatest common factor on the outside. So your greatest common factor goes here, which was 3. And then we rewrite it as a product. So 3 times what number gave us 27? Well, that was 9. And 3 times what number gives us 39? That was 13. Okay. Essentially, if you look at it this way, what we're doing is we're dividing this by its greatest common factor. So 27 divided by 3 gave us 9, and 39 divided by 3 gave us 13. Okay? And then we're just saying we're multiplying both by 3. What we just did is we factored. Okay, that's what it means to factor. It's kind of like doing the distributive property in reverse. Might seem extremely confusing right now. Again, I expect that. That's okay. Let's take a look at example 2. All right, we're going to factor again. It says factor the sum of the terms as a product of the GCF and the sum. Okay, same as we just did, except now you'll see that we've got a little bit of algebra involved. Okay, so our first term is 12b, and our second term is, oops, I forgot my b, 28. Okay. The GCF of these two terms is, and they tell us it is 2 times 2. Okay. In other words, 2 times 2 is 4. That's kind of a weird way to think about it. But if we could rewrite 12 as a common factor of 2, we would say it's 2 times 2, which would be 4, times what number is going to give us 12? Well, that would be 3. And then don't forget about your b as well. So 2 times 2 is 4, times 3 is 12, times b is 12b. Plus, how do we write 28 as the GCF of 2 times 2? Well, again, 2 times 2 is 4, and 4 times what number is 28? That would be 7. Okay, so 4 times what is going to give us 12b? Well, if we divide it by 4, we would get 3b. And divided this by 4, we would get 7. All right, so when we just apply the distributive property, well, we're multiplying by 4 twice here. So that's what goes on the outside of my parentheses. And then what am I adding? I'm adding 3b plus 7. Again, I took my original 12b plus 28 and I asked myself, I think this is the easiest way to do it. What is the greatest common factor? Well, that's 4. So that's what I'm going to multiply by. And then if I divided each of these by 4, 12b divided by 4 would be 3b, and 28 divided by 4 would be 7. Same thing as what I got here. Okay. All right. Let's flip to the next page and try out the next few problems. It says, for example 3, write 4 equivalent expressions for each given expression. So we're given 9 plus 15, and essentially what the book is asking us here is to rewrite this problem in 4 different ways. And they kind of give us the instructions here. So first it wants us to factor the expression as a product of 3 and a sum. So they want us to take 3 out of both of these numbers. Well, 9 divided by 3 would be 3, plus, don't forget about your addition sign, and what's 15 divided by 3? 5. Okay. For the next one, apply the commutative property to the sum. Remember, commutative means to switch positions. So 3 times, and now I just need to switch positions of these two. 5 plus 3. Next, it wants us to simplify the sum. Okay, can I take 5 plus 3? Yeah, that would give me 8. I still need to multiply that by 3. And lastly, it wants us to multiply. So 3 times 8 is 24. Okay, let's check and see. Are all of these equivalent expressions? Is 24 equal to 9 plus 15? Yeah, because 9 plus 15 is 24. Is 8 times 3 equal to 9 plus 15? Yeah, because 8 times 3 is 24, and so is 9 plus 15. The distributive property, what is 3 times 5? 15 plus, what's 3 times 3? 9. 15 plus 9? That's 24. Okay, so you can see that these are equivalent expressions because they're all equaling 24. All right, let's try letter B. First, tells us write 25 as a power of 5. Okay, 25 as a power of 5. Well, that would be 5 squared because 5 times 5 is 25. And I can't forget about my m minus 5m. I didn't do anything with that portion of it. So again, this is equivalent because 5 times 5 is 25. It's just another way to write that expression. Next, it wants us to factor the expression as a product of 5 and a difference. So it wants us to go back to our original and take out 5. All right, if I divided 25m by 5, that would give me 5m. And then I'm subtracting. And if I divided 5m by 5, I'd just be left with m. Okay. Next, it wants us to simplify that difference. So, in other words, what is 5m minus 1m? Well, imagine you had 5 m's, 1, 2, 3, 4, 5, and you took away 1. Now how many do you have? Well, you have 4. So this is the same as 5 times 4m. And then lastly, it wants us to multiply. So 5 times 4m would give us 20m. So take this times 5. Well, again, there's 2 times. There's 3 times, so on and so forth. And you'd get a total of 20m. Okay, so again, it just wants you to see all of these are saying the same exact thing. Because what would happen if you took 25 m's and you subtracted 5 m's? You'd be left with 20 m's, exactly the same thing we got here. All of these are equivalent expressions. And let's finish with letter C. It says, apply the distributive property to the given expression. Okay, remember, when we're using the distributive property, we're multiplying everything on the outside, so 2, to everything on the inside. 2 times 4p is 8p plus 2 times 2 is 4. So it's the same as 8p plus 4. Next, it says factor the expression as a product of 4. So I'm going to take out 4. Okay, and I'm going to ask myself, what is 8p divided by 4? Well, 8 divided by 4 is 2, and bring p along for the ride. And 4 divided by 4 is 1. Okay, factoring is done. Apply the commutative property. Remember, for the commutative property, what does that mean? Okay, apply the commutative property to the sum 8p plus 4. Oh, okay, so that just means it wants us to switch the position of this. So that would be 4 plus 8p. We're just switching the order. That's all commuting means. And then lastly, factor the expression as a product of 2 and a sum. So now it wants us to take out 2. Okay? 4 divided by 2 would be 2 plus 8p divided by 2 would be 4p. Again, all of these are saying the same exact thing. If you look at this expression compared to what we started with, it's almost identical, except your 4p and your 2 are switched around. All right. That brings us, last but certainly not least, to the check it out problems. There are 3. Please, please, please pause the video now and try them on your own. It is for your benefit. Okay. Number 1, factor the sum 48 plus 20 as a product of its GCF and sum. Okay, what is the greatest common factor of 48 and 20? Hopefully you found that it was 4. And that is what you need to factor out. 48 divided by 4 will give me 12. Plus 20 divided by 4 would be 5. Okay. Hopefully you came up with that. Next one, factor the sum 16 plus 56n as a product of its GCF and sum. Same thing. What did you get for a greatest common factor of 16 and 56? Hopefully you came up with 8. So dividing 16 by 8, you get 2 plus, and 56n divided by 8 would be 7n. All right. And then lastly, write 4 equivalent expressions for 12y minus 6y. Okay. Well, some things you could do is you could take out different factors. So say if I took out a factor of 2. In other words, I'm dividing this by 2. That would give me 6y minus, dividing this by 2, 3y. That's one way you could do it. You could actually just subtract these. 12y minus 6y, that would be 6y. That's another way to write an equivalent expression. You could factor out 3. So these both have a common factor of 3. So 12y divided by 3 would be 4y minus, and 6y divided by 3 would be 2y. All right. You could even factor out 6 because they both have 6 in common. So 12y divided by 6 would be 2y minus 6y divided by 6 would be 1y, or just y. Okay. So there's an example of how to write 4 equivalent expressions there. All right. Like I said, might have been a little bit tricky for you. That's okay. It's the first time you're seeing it. We'll get some practice with it. Let me know if you have more questions and I can help more. I would definitely recommend going to watch the video tutorials in your online textbook as well so you get some more practice with this. As always, be kind to one another, and I will see you next time.